Next, we're going to look at the SN2 reaction mechanism. Once again, the S in an SN2 reaction refers to substitution, and the 2 would refer to the amount of things involved in the rate determining step. In an SN2, it's two things, obviously. That would be the nucleophile and the product. This will be explained later on. It is important to note in an SN2 reaction, the nucleophile attacks the molecule like so at the same time as the halogen leaves. So there's no carbocation intermediate formed. And what I've done there is actually the mechanism itself, which is very simple. So we'll go over that again. The leaving group leaves, and at the same time that the leaving group is leaving, the nucleophile attacks like so. It is important that the nucleophile actually attacks the opposite side to where the leaving group will leave. Now, the second thing to note is that this bromine here is facing towards us, which is what the wedge means here. If it was facing away, it would be more like this chlorine, which would be dashed, which means it is facing away from us. Because this is facing away from us, it will actually change our product. For an SN2 reaction, the product is always inverted. This means that since the bromine is facing forward here, that in the product, the nucleophile that attacks it will come in from behind and form the opposite. So it would be like so. It would be dashed and then nucleophile. We'll see the same thing in example 2. We have the nucleophile here, Nu-. We have the leaving group, which is chlorine. The chlorine is now facing away from us, denoted by the dashed lines. So what we need to do is draw the leaving group leaving, and then the nucleophile will attack from behind the halogen, like so. And then the product will be inverted because the halogen is facing away from us, like so here. If there's any stereochemistry, which is the wedge and the dashed, they just need to be flipped. So in the product, we'll have something like this. So the leaving group was dashed before. So now the nucleophile needs to be wedged, which will then make this carbon here into a dash. So the most important thing to realize in this is that when you do an SN2 reaction, there is always an inversion of stereochemistry. Looking at example number 3, we have iodine here, which is the leaving group. It is facing towards us, as we can see by the wedge. We're going to react it with a nucleophile, so it's going to be denoted as Nu. The first thing to do is show the leaving group leaving, and the minus charge of the nucleophile goes behind the leaving group, which will result in this product here. Now the iodine is facing towards us, so in the product it is going to be facing away from us. And there you go, that's the basics of the SN2 reaction mechanism.